Hello, hello. Happy whatever day you are watching this. We are so close to finals and things are just getting down to the wire. Today we're talking about comparing linear equations, whether we're given them in a table, an actual equation, maybe a story problem, a graph. It's all about comparing. So today really combines everything that we've learned so far about linear functions, and it's super important for our summative tomorrow, and then also for finals coming up. So love this lesson. It's very complex. So we're going to go through 4 different problems here, and I'm going to try and model and maybe ask you to pause and try to figure out something, and then you'll go on into independent practice. If you feel like starting off with the mild, you can start off there. Otherwise, you can go right down to the medium. The medium problems are exactly like these ones, except just different problems. You can see that number 1 here, we have a table asking which one charges quicker and creating an equation. Same thing here, we have a table, who runs faster, create an equation. Number 2, comparing an equation and table. Number 2 in IP, comparing an equation and a table. So all 4 problems we are about to do are for your use when you're working on independent practice to go back to and use for help. So let's look at this first one here. We have Jolene wants to take her cell phone and Nintendo Switch to Mexico. An hour before her family planned to leave, she realized that she forgot to charge them last night. At that point, she plugged in both devices so they could charge as long as possible before she left. Jolene knows that her phone is dead, has 0%, and that the battery charges 2% each minute, and that is her rate of change or her slope. So her phone has a rate of change or slope of 2% each minute. Her Nintendo Switch is new and she's not sure how fast it charges, but has the data right here. Which device charges quicker? And we're talking about the rate of change here, or her slope. So the slope of the phone is 2, and I want to know which charges faster, which one has a higher slope. So we're given our slope for her phone, we just need to find her slope for the table. Now we know our equation for slope, y2 minus y1, x2 minus x1. So we can say this is x1, x2, oh my goodness, come on. This is y1 and this is y2, and we can calculate the slope. If you know how to calculate the slope, please pause me now and find the slope for her Nintendo Switch, her rate of change, and then come back and see if you got it right. Go ahead and pause me if you know what you're doing. Otherwise, hang with me. Alright, so we take our y2, 40, minus y1, 30. And then on the bottom, we go x2 minus x1. So 10 minus 0. 40 minus 30 is 10. 10 minus 0 is 10. And we know that 10 over 10 equals 1. So that means her Nintendo Switch charges by 1% each minute. So 1% each minute. Okay, so now we can go ahead and answer the question. Between the phone that charges at 2% each minute and the Switch, which charges at 1% each minute, which one charges quicker? And we would say her phone, because 2% is larger than 1%. So we'll say her phone charges quicker. Okay, and then I say create the linear equation for her phone. So we know that linear equation means y equals mx plus b. So what is the slope for her cell phone? Well, it's that 2. Which one charged quicker? Her cell phone, we knew that because it was 2. So we have a rate of change of 2. And then her phone is dead and it has 0%. So that means its starting point is just 0. And you don't have to include that. You could just say y equals 2x if you wanted to. Okay, and then we go on to the next question. We have she has a third item she wants to bring that charges 3 times as fast as the Switch. If it is dead and has 0 charge, write the equation to represent that item. Okay, so there's 2 pieces of information here we need to know. Number 1, that it charges 3 times as fast as the switch, and the switch is 1% each minute. So if it's 3 times as fast, we can multiply it by 3. So that means this new item charges at 3% each minute. So now we have its slope, and then we also already have its y-intercept, its starting value. It's starting with 0. So go ahead and write the equation for this new item. So we have a slope of 3x, and then again you can say plus 0 or just leave it as 3x. Great. Okay, so that one is now done. Well done. Again, this is just like number 1 in the independent practice. Let's go on to the next one. Now we have which function has the greatest rate of change, the greatest slope. So we have an equation and a table. So let's start with finding the slope from my equation. First thing we need to notice is that it's in standard form. So we need to change that to slope-intercept form, which means we just need to solve for y. So go ahead now, pause me and solve for y, and start doing that by moving the 9x. All right, come back when you're ready. Pause me now. All right, so we add 9x to both sides, and we get 3y equals 18 plus 9x. And then we have 3 times y, so we divide every single thing by 3. 18 divided by 3 is 6. 9 divided by 3 is 3. Okay, it says which has the greatest rate of change, so we need to know which is my slope. Is it the 6 or the 3? It's that 3, that number next to my x. Okay, now we need to find the rate of change from the table. And we do that just like we did up here. y2 minus y1, x2 minus x1. So let's label those points. We have x1, x2, y1, y2. All right, go ahead and pause me and calculate the slope or rate of change of our table. Come back when you're done. All right, so we take our y2 minus our y1, so negative 4 minus 16. And then we take our y2, or x2 minus x1. Negative 4 minus 16 gives us negative 20. 12 minus 8 is 4. So that means we get a slope of negative 5, because 20 divided by 4 is 5, and then opposite sign, so my answer is negative. All right, so then that's my slope of my table. So it says circle 1, function A or function B has a higher rate of change, between 3 and negative 5. Which one's higher? A. 3 is bigger than negative 5, so we can circle function A has a higher rate of change. All right, now onto graphing. We have function A is given by the graph right here. What is the equation of the line graphed to the left? All right, so let's go ahead and create this equation. We have a point down here and a point right here. All right, go ahead and find your slope by finding your rise over your run. Pause me now and find your slope. Come back when you're ready. Okay, so we have 1, 2, 3 over 1, which is just 3. Okay, what's our y-intercept here? Where does it cross the y-axis? Up here at 4. Okay, so now we can create the equation of the line. Go ahead and create your equation. Remember, it's y equals your slope, x, plus your y-intercept. So we have y equals our slope, 3x, plus our y-intercept, 4. Okay, now let's see what this says. It says, which of the following functions of these 4 has a rate of change that is greater than function A? So what is my rate of change of this? Is it 3 or is it 4? 3. Okay. So we're trying to figure out which one of these has a greater slope than 3. Alright, so I see 2 right away that are solved for y. So I can pull my slope from these, bam, right now. What's my slope of function d? What can I imagine it is when there's nothing there? 1. So is 1 greater than 3? No. So I know that's not an answer. Okay. Over here we have 7 divided by 2. What's 7 divided by 2? 3.5. So my slope for this one is 3.5. Is that bigger than 3? Yeah. So function b is for sure 1. Now we have 2 other options here. This is why in the do now, if you were with me, we would have had a practice problem of solving for y. We don't. You don't because you weren't here in class today, but let's go ahead and do it. So again, when we are given an equation where we have x and y on the same side, we don't know what our slope is. So we need to solve this for y so that way we can find our slope. So in order to get y by itself here, we have to move that negative 2x. How can I move my negative 2x? By adding it. So we have plus 2x, and we get y equals 21 plus 2x. Okay, I now have y by itself, so now we can find my slope. Is my slope 21 or 2? 2. Okay, is that bigger than 3? No. So that's not an answer. All right, we have one more left here. All right, so again, let's solve the, let's go ahead and solve this for y. All right, so if we want y by itself, what do we got to move first? That 12x. How do I move a negative 12? Adding 12 to both sides. And we get 2y equals 20 plus 12x. Okay, y is not by itself yet. I have a 2 there. How do I move that 2? What's the opposite of 2 times x? To divide. So we get y equals 10 plus 6x. All right, what's my slope of that one? 10 or 6? 6. Was that bigger than 3? Yeah. So we got 2 answers there that are bigger than 3. All right. We have one problem left. All right, so we have problem 4. The table below represents a linear function. Circle the equation below that has a smaller slope and smaller y-intercept. Okay, so first up, the table represents a linear function. If I'm trying to convert the slope and y-intercept, I need to find the slope and y-intercept from my table. So let's go ahead and find the slope here. Oops. X1, y1. So we do 0 minus negative 2, 7 minus 5. We get 2 over 2, which equals 1. Okay, and then now we go ahead and plug in our slope and a point. So let's plug in 7 and 0 here into y equals mx plus b. So my y value is 0. My slope is 1. X is 7 plus b. 0 equals 7 plus b. Subtract 7 on both sides, and we get negative 7 equals b. So that means my equation is y equals 1x minus 7. I want to know which one has a smaller slope and y-intercept. 3x is not smaller than my slope of 1. 1/2 and 3x are both smaller than 1. But now I need a smaller y-intercept between negative 7. That is negative 7, so that is not smaller. Negative 8 is smaller than negative 7. So that's my answer. All right, sorry I flew through that, but you have your independent practice now to do. Make sure you go back up and look at problem 1, 2, 3, and 4 to help you out. Let me know if you have questions, and have a good day.